So now let's go ahead and take a look at how we would actually compute some probabilities with a uniform distribution. So let's take a look at part D. What is the probability that a given assembly will take somewhere between 30 and 35 seconds? Okay, well, we could go ahead and try to first start to represent what it would mean to have an assembly time occurring within this range. And to do that, I'm going to kind of reattempt to draw this picture that I have down below on part D. Okay, so let's see. I'm going to go ahead and just quickly sketch out, again, a little x-axis. I'm going to have on here my values, which go from 27 up to 39. I know that there's also going to be this kind of horizontal bar that stretches across the top. Looks like this. And now I'm going to go ahead and mark down where my center point is. I know that my center here was at 33. And I can see that in this case, I'm interested in existing between 30 and 35 seconds. So 30 to 35. Now I'm just kind of eyeballing roughly where those numbers would fall on the number line. And what I can do is I can keep in mind that if the total area under the curve, the total area under here is supposed to be a value of 1. But I only want this shaded space, that is, the shaded space that was between 30 and 35 seconds. So I can ask the question, how much total area is this? Well, interestingly, it's super easy to go ahead and calculate that, because if you look at what this shape is actually just, well, I guess a rectangle. If I know how long it is and how tall it is, I can find its area, and that area corresponds to a probability. Now, the easy way to go ahead and calculate that is shown in the box above, but also on the formula sheet. I'll write down first in symbols what I'm looking for. I want the probability that my x, the time it takes to produce the module, is between 30 and 35 seconds. Now to compute this, you'll see that up here I have listed down that I should just take my right minus my left over the b minus the a. So kind of like the length of my blue stuff over the length of everything. So if I go ahead and compute that, I'll notice that this is going to be 35 minus 30, that's the length of my blue stuff, over the length of the entire interval, 30 minus 27. Now, in the formula sheet itself, I don't have things listed in precisely this way, which is a bit unfortunate. It's just kind of more of a typo on my part. Here I have an x1 and an x2. If you have your formula sheet with you, I'd recommend just change that to an R and an L to make things easier on you. You know, you're just doing your right side minus your left over your B minus your A. Now, once I have that, I can just simplify down this. I'm going to get 5 over a value of 12. And so the probability is 5/12. Or if I type that into a calculator, I'm going to get 0.4167. That's it. It's just that simple. I don't even need a calculator, except maybe to get the decimal value. But I don't have any fancy program to do this. Let's take a look at something like part E that asks a very similar question. What is the probability that the given assembly will take fewer than 30 seconds? Okay, I'm going to go ahead and I'm going to pretty much every single time redraw out my picture so I understand what's going on. So again, I have 27 to 39. I'm going to go ahead and create a nice little line to exist above that. That one's not drawn perfectly, but oh well. Let's see, I have my 33 here in the middle, and now I want to go below, I want to go fewer than 30 seconds. Okay, so this is roughly where 30 is on the number line. And if I go lower than it, that would be going over to this direction, right? Until I've run out of space. Okay, so I can go ahead and think about how I'd write this. I want the probability that x is below the 30 mark. So I'm going to take right side of my blue minus left side of the blue. So 30 minus 27, length of the blue, over length of the entire interval, which is going to be 39 minus 27. So let's see, that would be 3 over 12. Ooh, and 3 over 12, that's actually just 1/4, or exactly 25%. So there's a 25% chance that the module will take under 30 seconds to produce, while there's a 41.67% chance it'll take between 30 and 35 seconds. Okay, Here's an interesting one. What's the probability that the given assembly will take exactly 30 seconds? Okay, just like before, the way that I help process the information is by having one of my curves written out. So I'm going to go ahead and redraw this again. You'll see me do this on pretty much every single question. Every one that I do in the notes, every single one that I do in the worksheets. This is how I process the given information. Okay, so I have my picture here. I know 33 is right there. And now I want the probability that it will take exactly 30 seconds. Okay, so here's 30. And this is, going to be where 30 exists. And do I want to shade up or down? Well, that actually doesn't make sense really either way, right? I want exactly 30. So I don't want to go below 30. I don't want to go above 30. I want to stay at exactly 30. Okay, no big deal. That's fine. I guess that's what my picture is going to look like. So I want the probability that x is going to be exactly 30. Well, when I look at this, I'm going to have to do how long is my blue rectangle? That is from left to right. How much blue shaded space do I have left to right? Well, if I'm starting at 30 and kind of stopping at 30, I'm going to get something kind of interesting. My blue stuff is going to go from 30 to 30, while my entire big rectangle goes from 39 down to 27. So I'm going to get 0 out of 12. In this case, 0. The chances of actually getting the module produced in precisely 30 seconds has probability 0. Zilch. Not gonna happen. This is a very strange fact, because this is something that actually will be true in every single continuous distribution. The probability of exactly 1 moment happening, of exactly 30 seconds, is going to be 0. Notice I get the same thing if I asked, what about exactly 33? Not going to happen. Instead, I have to look at ranges of values. What that's going to mean, though, is that actually on all of my previous problems where I had something like a less than or a greater than sign, I could have actually put in a or equal to, because adding on this or equal to doesn't change anything. Those green or equal to portions could be included or excluded. It doesn't matter, because the probability at that single point is nothing. Okay, let's take a look here at one final question in this section that's kind of a reverse style question to what we've just been looking at. How slowly would a module have to be produced if it was going to be in the top 10% of all module production times? Okay, first I should pause and notice there's a big change between this part and the previous parts. In the last 3 questions, I started each of these with, what is the probability, right? My goal was end with the percentage, end with the percentage, end with the probability, right? That's what I was looking for. But notice here, in part G, I'm asking, how slowly does a module have to be produced? So my answer is going to sound something like 10 seconds, 13 seconds, 27.9 seconds, right? I'm going to get some amount of time as an answer here. So let's try to draw a picture, though, to help understand the scenario again. Again, I'm going to do this on every question. I highly recommend you do the same. So let's see. I know that the module production times are somewhere from 27 to 39. I know that I have a uniform distribution, so I can draw my curve looking like this. I know that my average is right at 33. Okay, so here's my picture. Now, I'm apparently going to be looking for a value of x on this number line because I want to know how slowly would a module have to be produced. I'm going to look for some number down here on this number line. What I know, though, is that wherever this item is, wherever this time is, it's going to be in the top 10% of all the module production times. Well, let's go ahead and shade an area then that corresponds to this top 10%. So if I'm in the top 10% of production times, that means I'm taking a long time to produce things. So maybe I'm in a production time that exists over here, right? And this amount of time, maybe this amount of space, corresponds to 10%. And so the question that we have right now ultimately is, where does that start, right? I mean, obviously it starts at a number that's less than 39, but what number? Does it start at 37? Is it at 35? I have no idea. So what I'm going to do down here is I'm just going to list this as a value of x. I want to find that x. I want to find that time. Well, notice I can still set this up with a nice little probability notation. Now, I'm going to first make a big distinction that over here on the side I have a capital X, and down here I'm just putting a little x. So notice how I'm using that in my probability notation here. What I know is that if I wanted to calculate the probability of this blue stuff, right, I wanted that space, I know I would say I want the probability that big capital X is between little x and 39. I know that the way I would have calculated that in all the previous problems, like if someone gave me this x value, I know I would do 39 minus x over 39 minus 27. I know that would be 39 minus x over 12. But now I know something extra in this question. I know that when I compute out the total amount of blue space, it should correspond to 10%. So I know that this should actually be equal to 0.10. That's a given. So maybe now we could solve for that value of little x. I'll even say that here. We can solve for little x. We know that 39 minus x over 12 has to be equal to 0.10. We're back to algebra class. So let's see. I could start by multiplying both sides by the value of 12. That would get me 39 minus x equals 1.2. I could then go ahead and add x to the other side. 39 is equal to 1.2 plus an x, and then subtract the 1.2 over. And if I do that, I think I end up with 37.8 is equal to x. So, how slowly would a module have to be produced? I can easily write that out. I could say it would have to be produced in 37.8 seconds or more to fall into the top 10% of production times. There it is. So even when I get questions that may ask this kind of strange backwards sort of question where I want an x value, not a blue probability, I should hopefully still be able to reason through that. It'll be something very similar to this process pretty much every single time.